All right. Happy Thursday or Friday, whenever you are watching this, guys. I hope you are doing well. I am doing well. It's a bit late on Wednesday night. And yeah, we're going to go ahead and work through this assignment together. So this is I think it's 3 pages. Yeah, 3-page assignment for our new guided notes that are going to be, that we're going to be working on for the next few days. So that's a brief introduction, and let's go ahead and get started with this. So, as you remember, you are I will tell you exactly what you need to do for these guided notes. If you have any questions, you can let me know, and you can ask me right now because you are probably listening to this and hopefully listening to this during class. So, just leave or pause the video and leave your breakout room if you're in a breakout room, and then ask me a question. And if you're not in a breakout room, just shoot me a message. So perfect. That is the plan. I should be hopping from breakout room to breakout room. So remember, if there's 2 of me, it's probably not. It's probably because there are 2 of me and that I'm trying to talk to you outside of this video. So that's the plan. Let's go ahead and get started with these. So first off, our objective. Now I have our objective written right here. And your copy, I don't think is going to show the objective. So I want you to type that out. And if you need to pause it, that's totally fine. So our objective today is I will be able to construct a proportional equation from a given proportional table or proportional graph by completing asynchronous guided notes. That's exactly what I told you guys we're going to be starting on today. So that we're already set. Now, we're going to review some stuff. So there are 2 equations that we really need to review here, and those 2 equations are below. Now, I didn't finish those because I want you guys to try and think about these 2 equations. What is missing right here right here in this equation, and what is this fraction right here made up of in this equation, the top and bottom? So go ahead and pause and think about it for a second. Now, if you have been paying attention at all in class, you know that this is x times k equals y. Now, I'm just going to notice I'm going to mention formatting stuff on occasion here. So this is a new thing where I'm putting equations in the formatting. So there's a fancy way to do that. Try and keep equations in equations. So if, that sounds like goofy, but it allows us to make fractions like this in a way that we couldn't before. So do your best to not delete these little boxes that they're in and keep them there, and just fill them out within there. So x times k equals y, and k equals what? What does k equal? Well, I think it was k equals y over x. K equals y over x. These 2 things right here, I cannot emphasize enough how important these are, right? I cannot emphasize enough. So these 2 equations are the most important part of what we're going to do. And if you have these 2 things memorized and know how to use them, then you will be literally set for the entirety of this lesson. So let's go ahead and let's keep moving on. Now you're going to have a new definition here. Our constant of proportionality, and I'm also doing some final edits as we do this, right? I don't know why that was an equal sign. Too much math, apparently, right? Constant of proportionality. So if you remember last week, we created a math vocab index, and I told you to not fill this out. This is your chance to fill this out. You can copy and paste it if you want. If you don't remember where that is, I'm going to have that accessible to you on Monday, but you are supposed to be taking charge of that. I cannot find your own and find every single person's like in the snap of my finger. So that's your job. Find your math vocab index. That's another homework assignment. So for you this weekend if you can't find it. So constant of proportionality is the unit rate of all y-x relationships for a proportional relationship. So, the unit rate of all y over x relationships for a proportional relationship, guys, are the same. That's what we're missing right here. Are the same. They need to be the same. So that means that we've done this before, but that means that As we connect y and x, y over x gives us the same number every time. And x times a certain number equals y, and that certain number, k, is the constant of proportionality, right? So we know what that is. Now, those are the three things that we need to know before we do this. And then the other things we need to know are here. I have these called inquiry questions because I don't really want you to answer them. So you're not going to type here. And if you did type, I know you didn't listen, so don't type here. What is an equation? So what's an equation, right? So an equation, as I have here, which you guys won't be able to see, is a math sentence with an equal sign. That is exactly what an equation is, a math sentence with an equal sign, right? Okay, that's all that an equation is, a math sentence with an equal sign. So this up here is an equation. This is not an equation. It's kind of like I say sentence because it works like that. You need a noun, you need a verb. You need variables, but you also need an equal sign. An equal sign is what makes an equation. So this is not an equation, but these are equations, right? Because they have equal signs. So that's what an equation is. And you don't have that on your paper. Where have we used an equation when talking about proportional relationships? I kind of gave that away just now, didn't I? Oops. Right here. These are both equations, and they are so important. We're going to use them almost exclusively during this lesson. So these are really good. Next up, finally, are these equations actually okay ways to show proportional relationships by themselves? So like, can I show or represent a proportional relationship with just an equation? Is that possible? Or do I need a table or a graph like I've done before? Can I use just an equation? And as you see right below hand, yes, it is the best way to represent a proportional equation. And we might be able to see that later, but you have to trust me right now. This is the best way. It is so nice and easy, guys. So and it's kind of like the final way to do that. So yeah, there you go. Now we're going to move on. Oh my goodness, I just had some ice cream, you guys. My stomach is a little bit excited, so there you go. Fun fact that you guys didn't really care to know, but you always get those with me, right? Now, we will be using the equations x times k equals y, but we're not going to use that exact equation. I'm saying this again because it is that important. It is so important. I will explain it in a second, but we need to flip x and k, guys. We're not using x times k equals y for equations. We're going to change it, and it's going to be k times x equals y. With multiplication, order doesn't matter. So we're flipping that order, and that's because it's like math etiquette, right? So I've told you guys a little bit about math etiquette before, but that would be like, I know in Spanish you actually do this, but if you switch around like the order of words that you're saying, it's like, yeah, I know that if I say, oh, look at the car red, like I know what they're saying, but it's not right. So this is the same thing. If you say X3, I know what you're saying, but it's not right. So make sure that you have the number and then the variable. Number and then the variable, right? So perfect. That's what this is going to be. Number and variable might be confusing to you right now. Trust me, it'll make sense in a moment. So bear with me. K and then X. K and then X. Sorry, that might be a little confusing, but it'll make sense in a moment. Now, with that said, we're going to use this equation for example A. Let's look at example A here. So, use the following table to create an equation for a proportional relationship. I'm going to zoom in a little bit, guys, here. I'm going to zoom in so this is just a bit easier for us. So I need to use this table and make a equation. Okay. I guess that's easy enough, right? Oh my goodness. Excuse me. I told you that ice cream got me bad. So let's go ahead and try this out. Now, I have right here x, 2, 4, 6, and y's of 5, 10, and 20. The 2 and the 5 are connected, the 4 and the 10 are connected, and the 6 and the 20 are connected. Now, some of you might be thinking, oh, well, I have an x right here and a y right here, and I have an x and a... So, oh, I just plug in x and y. Okay, let's try that out. Let's try that out. Let's see what we get. That would give us like k times 2. Ooh, this is such a bright green. I don't love it. Equals 5. K times 2 equals 5. This is true. K times 2 does equal 5. But is this what I'm going for? No, it's not what I'm going for. An equation, like technically this works as an equation, yay, but that's not the goal. Our goal here is to reach a standardized form. So a standardized form means we need to have the same exact format every time, right? So in the same way that we have like a first, middle, and last name, right? First, there's 3 parts to something, they need to be in a certain order. My name is Benjamin Taylor Van Vliet, but no one calls me Taylor Benjamin Vliet Van or something like that. No one does that. So we need to make sure that our order is correct, and that order that we're going to do means, well, actually the only thing that really matters in that order is that we get k first. So we need to find k first. So how do we find k again? How do we find k? And what does k even stand for? Well, just a reminder, k is the constant of proportionality. But I want you to think, how could we find k using this data here, this table? You've done this before. Okay, let's see. Well, isn't there an equation right up here? Let me go ahead and erase all this. Isn't there an equation up here that's going to be helpful for us? Maybe by the name of k equals y over x. That is correct. This is the equation that we need to use right here. K equals y over x, okay? So let me go ahead and did that? Oh my goodness, you guys, this is the coolest thing ever. I love this recording tool because I'm scrolling and that line stayed there. That is so cool. Holy cow. Okay, I'm just mostly completely entirely excited, but that's okay. That's okay. No big deal. I'm not going to get out of control here. I'm going to change this to a bit of a darker color so that it's easier to see. So let's go ahead and find k by saying k equals x over y. Now, I can tell you right now that this is proportional, and I'm just telling you that as I'm just going to say it. You have to believe me, that is proportional, and we can test that for the next few, and we will. For all of the next ones, we will test it. But for now, all we need to know is k equals x over y, and we can use this x and this y. So k equals 2 over 5. Ugh. Is that pretty? No, no thanks. It also equals, let's change colors here real quick. It also equals 4 over 10. Ooh, that's just as bright. And 4 over 10 simplifies by dividing the top and the bottom by 2 to get 2 over 5, right? Awesome. So 2 over 5 works, and that is going to be our k value. Now, here's the kicker, guys. Here's the awesome part. All we need is k. Yes, you heard me correctly. All we need is k. So what we need to do here is just simple as day, k times x equals y, right? Ooh, the pen tool here is not as good as Zoom's. Zoom's pen tool is really good. So pardon this for all of you art enthusiasts out there, especially in 7th period. Shout outs to you guys. But kx equals y. Well, what's my k? K is 2 over 5. So this just turns into 2 over 5 x equals y. And ladies and gentlemen, that's my answer. What? Okay, wait. Mr. V. You're saying that we can leave x and y in there and that's okay? Like, but that doesn't make sense. We need to find them. No, actually, we don't. One of the cool things about equations when it comes to 2D space, Euclidean space, those are fancy like college words for like a graph, is lines have like a bunch of answers, right? So 2 and 5 will answer this equation correctly, right? 2 and 5 will answer this equation correctly. And guys, I just realized I made a huge mistake. Oh my goodness. If you guys caught my mistake, shout outs to you guys for catching my mistake. Oh, this is so embarrassing. I'm not going to re-record this because I spent so much time on it, but my mistake is pretty obvious to those of you who are paying attention here. It's pretty embarrassing. I'll give you a second to think of it. But hopefully that what I just did there is proof. K doesn't equal x over y, does it? What does k equal, class? What does k equal? What a freaking brain fart, guys. K equals y over x, which gives us 5 over 2. So this is going to be 5 over 2 x equals y. That is the correct answer. So what I want you to do now is I want you to go ahead and click this x right, or this k right here, and I want you to write 5 over 2. You can write it just like that, and you'll get full 2 thumbs up for that. 2 thumbs up for that. Now remember, we found k by using the equation k equals y over x right here. There's another fancier version of it down here, k equals y over x, right? So we used k equals y over x to find the equation. Now we also, excuse me, on top of using k equals y over x, we needed to plug in k into the equation kx equals y. K times x equals y. Since k was 5 over 2, we just plugged it in, and we keep x and y as themselves. Maybe in the future we're going to be dealing with solving those and trying to figure that out a bit more, but this is a standard equation. In fact, this is an equation that I would use as like an adult, and equations that I use all the time as adults. They look just like this, right? So that is awesome. Let's go ahead and move on here, and I want to talk about the steps here for these next few questions. So our first step is we're going to need to check if the relationship is proportional. And we're going to do that by seeing our value of k. Our second step is going to be, we're going to find k by using k equals y over x. Ooh, popped a knuckle there. So using k equals y over x, just like we did up here, right? Y over x, not x over y. Mr. V, what are you doing? Oh my goodness. And then we use that. Now for a table, it's easy right here, y and x. And for a graph, it's just as easy. We just use a coordinate on the graph, right? So for a graph, we use a coordinate. For a table, we use a row. Now finally, you plug in k to the equation, kx equals y, and that gives us our answer. So our answer for this last one, well, we checked if it was proportional by seeing that 5 over 2, 10 over 4, and 20 over 6. This is supposed to be, I promise you guys, this is 15 over 6. That this is proportional because all of these are going to give you a 5 over 2 value. So with that, we checked if it was proportional. We found k as 5 over 2 by doing x is 5, or by doing y over x. Y was 5, x is 2, and you could do that with all of them. You could do it with this option we didn't even look at, 15 and 6. 15 divided by 6 is going to give you the same thing as 5 over 2 if you divide 15 and 6 by 3, right? Now let's go ahead and then the final step is to plug in k. Now let's go ahead and do this first one together, right? So let's do this first one together. So our first step is to check for proportionality, right? So I'm doing our first step in red, or in, no, our first step's in green. Our first step's in green. Is this proportional? Well, I see here 1 and 4. So my unit rate here is 4 over 1. That's my constant of proportionality. Let's check 8 over 2. Oops, let's erase that guy. 8 over 2. Well, I'm going to do this one right over here. 8 over 2. I can divide that by 2 over 2. And 8 divided by 2 is 4. And 2 divided by 2 is 1. Oh, 4 over 1. 4 over 1. And then 12 over 3. Guys, it's 4 over 1. And I can check that by bringing it on over here. Y over x goes to 12 over 3. Divide the top and bottom by 3 over 3. And I get 4 over 1. 4 over 1. Since these are all the same, boom, 2 thumbs up. That's perfect. That's exactly what we want. Now, the next thing that we need to do is we need to calculate what our k value is. So this is stuff that I was able to do. This is stuff that you are going to do on paper, but you do not need to do it on this document. What you do need to do on this document is you need to edit this on every single one of k equals question mark over question mark. We need to plug in a y value and an x value into here, just like it has over here, but we need to plug it in for the example. So my y value that I'm going to choose is in that first row of numbers, y value of 4. And the x value I'm going to choose is an x value of 1. So 4 over 1, perfect. Now, I want to remind you that we want to simplify this as much as we can. So if I see 4 over 1, y'all, I am not thinking, oh, that's perfect, I'm all done. I'm thinking, I think I can do more here. Maybe if it lets me. Oh, no. Oh, the equation. Oh, there it is. 4 over 1, which equals 4. So if you want to erase that fraction and just turn it into 4, you can do that. But that is what k equals. So, and guess what? This was my second step. Find k by using k equals y over x. Y over x, 4 over 1, k equals 4. Hey, could we technically, are we doing that step right here? Oh yeah, this is all kind of technically doing that exact same thing. So if you are able to find the constant of proportionality for each of these to prove that it's proportional, then you've done that second step already automatically. So those first two steps are kind of intertwined. They're connected to each other. Now the final step, plug in k. What's k equal? 4. 4x equals y, and that's it. We are done. It's that easy, Mr. V? Yes, it's that easy. It's that easy. Now, we're going to do a couple more together here, and I need you to do 2 independently. Work on 2 by yourself. I'm going to say that again. Work on 2 by yourself. Okay, now let's go ahead and work on number 3 together here. Number 3 together. Oops, it looks like our y over x is not scrolling with the rest of the stuff. It's a pretty cool system, but a little glitchy. Now, let's go ahead and check for our proportionality here. We have 1 over 1 and 2 here. We need to check if these are proportional by finding that y over x, our unit rate here. So 1 is our y, 2 is our x, right? You know what? I'm going to change where I do this. I don't like that being located right there. We're going to bring these out like this. So I have 1 over 2. And this is my y over x. That's an ugly one. Oh, still ugly. That's okay. Life goes on. Now in a different shade of green. Y over x. So we have 2. I'm going to make a little barrier here. 2 over 4. I can divide that by 2 over 2 because that's not fully simplified. This becomes 1 over 2. And guess what? Okay, fine, I'll do it. 3 and 6. 3 over 6 can be divided by 3 over 3, which equals 1 over 2. 3 divided by 3 is 1. 6 divided by 3 is 2. 1/2. All of these equal 1/2, so guess what our k equals, ladies and gentlemen? That is exactly right. k equals 1/2. And there we go. Perfect. Now, since that's the case here, you are going to do k equals 1/2. And if you put 1/2 and then you press space, oh, is it not working? That's okay. 1/2. That's perfect. There's a fancy way to put fractions in, but it's kind of tricky, so we don't have to do it. No worries. Now, 1/2 x equals y. That's it. Let's check our steps again real quick here. Sorry, these aren't going with it. I'll erase them real quick here. So our first step is check if your relationship is proportional, and our second step is find k by using k equals y over x. Now, I need to remind you that we have been checking for proportionality with tables by calculating k equals y over x, right? It's going to be a bit different now for graphs, though. And that final step, obviously, is plugging in what we found that constant of proportionality to be into our equation k times x equals y. One last time, check, see if it's proportional, find k, plug in k. 1, 2, 3. Let's do this. We're moving on. Now, finally, whoa, I thought I erased that. Guys, am I going crazy? We'll see in the playback here, but I thought I totally erased that. We have graphs now. I need to check if these are proportional. That's my first goal. Now, proportionality with graphs is different, and I can already hear some of you going, oh, Mr. B, I know how this is proportional or not proportional. You need blank and blank. Take some time to think what those two things are, and then I will write them here in one moment. What are those two things that determine proportionality in a graph specifically? Okay, here we go. The first thing we need, goodness, I missed an undo button like Zoom has. So sad. F in the chat for me, guys. F in the chat. So one, the first thing we need is a straight line. We need a straight. Oh, I promise you. Oh, yeah. Nope, I do miss Zoom. Feels bad. A straight line. Now, the second thing that we need is it needs to go through the origin. Y'all, all these are proportional. I can tell you that right away. I know you can't see 8 yet on my screen, but all of these are proportional. They all are straight lines that go through the origin. So this is checked for all of those. So I'm just going to erase it right away. They're all straight lines that go through the origin, right? And that's what matters. Now, what we need to now find out is what's k. And ladies and gentlemen, I can say it again, that equation k equals y over x is going to save, it's going to save so much time. We're going to be so set because of this. So let's do it. Whoa, these circles are so glitchy. I promise they're perfect circles. They're just acting up. If this graph is a little blurry and you're frustrated at it, if you double click it, it is less blurry. But then I don't want you to move these things around. So you can usually just be fine with it. And we can just find out our y and x. Now, one thing that's not on these graphs is where our y and x is. And y'all, we should know this by now. Our y is the vertical and our x is the horizontal, right? So I'm going to, oh, I think I turned my camera off there. Oops. Sorry, guys. I'm going to turn this back into an x. That's a normal x, not a crazy x. And we need to find out what's our y compared to our x. How far do we go up? How far do we go over? Now, we can do this by finding the coordinates. So I've knocked out a few of these coordinates already, but I didn't write them down for you. So what's our coordinate here? Let's see. Well, a coordinate is in the form of x, comma, y, right? X, comma, y. What is this coordinate? What's our x value here? What's our y value? Our x value is how far it goes over, and it goes over just 1. So x is 1. And our y value is how far it goes up, and it goes up 1, 2. 1, 2. So remember, this is x, this is y. Y over x. This is not 1 over 2. This is 1, 2, and that means we're going to flip this to be y is 2, x is 1. And you're going to write that in here. You're going to change k equals to 2. Oops, that's a weird one. 2. Oh, sometimes these equations make me want to go crazy. Keep trying. If it doesn't work, you can find another way to put it. Don't worry, I won't be upset or anything like that. But they look so much prettier. Now, k equals 2 over 1. I could also write this as k equals 2. Ta-da! Okay, cool, awesome. You are going to work on number... Oh, wait. That's not it, though, guys. This is something that happens. We forget that we're not done yet. K equals 2, and you can plug it in. 2x equals y. X and y stay x and y still. So the only difference here is how we find our k value. And we already know how to do that, y'all. We already know how to do that. So I'm going to let you work on 6, 7, and 8 by yourselves. And I know that's a little scary, but if you have questions, remember, I'm still here. You're still in a Zoom call. And if your first period, you might not be in that Zoom call anymore. But for the rest of you, you're still in a Zoom call. So just, ask me a question. Or shoot me an email if you're working on this after class. Please, that's an awesome idea. I love that. Or see if we can set up office hours for Monday or Tuesday. Yes, I love it, I love it, I love it. So that's the plan. And then the final thing that you're going to do is this Google Doc right here. And let me show you exactly what's here. It's really simple. Oh, it's not going, but it's just your name, your period, and it's one problem with a table. And I'm going to use that as a grade of yours. If it's done, it's a grade as well as this. But this is going to be a way for me to determine exactly how we're doing on this so far. So without further ado, this video has gone on super long. Super, super long. You guys have killed it. I hope you took some breaks in there. I wish I could, but yeah, great job, you guys. When you're done, go ahead and wait for what Mr. V's, what I need to say to you, but real time Mr. V needs to say to you, right? So yeah, I think that's it. I'm trying to think if there's anything else. Nope. Do your best here, and don't be afraid to ask questions. Please ask questions. Okay, cool. Have a great rest of your day, and I will see you in the future or in the present. Man, this is confusing. This is confusing stuff.